Hi, my name is Krisztian Fekete, and thank you for having me and joining me for this talk. This talk will be about OpenTelemetry, OpenTelemetry collectors, and other kind of OpenTelemetries, Prometheus, and which one you should use for whatever use case that you might have. This is actually a second edition of this talk. I already presented this talk last year at SREs in Dublin. There are some minor changes. You can see these. I will probably call those out. If you also want to check out the original recording, you can go on YouTube and do that there. All right. This is the answer. It depends. So thank you for coming to my talk, and the next presenter will have some extended slot. No, that was just a joke. So, but the answer is really it's a maybe, it's an it depends. There are trade-offs. The goal of this talk will be to bring these trade-offs up and the questions also, and I also want to highlight the questions that you should be discussing with your team if you are considering moving away from Prometheus or adopting OpenTelemetry. These will be valuable questions to discuss with your team, I think. My name is Krisztian Fekete. I'm working at Solo.io, the Istio company, the application networking company. We have telemetry pipelines in our product. I will talk a bit about our product just briefly as a case study, let's say, so that you can understand why in that specific use case OpenTelemetry might or might not make sense. You can find my contact information on this slide, so feel free to drop a note if you have any questions or if you want to discuss anything related to application networking or observability. Here you can see some information on my background. I won't go through all of these. This is just there so that you will believe me that I have also experience with other observability solutions, not just OpenTelemetry, and this won't be an OpenTelemetry pitch. So if someone came for that, those people might be disappointed. I even used Nagios before Prometheus, for example. I'm not sure how many people have used Nagios. Almost everyone. Okay, it was not that great, right? At least I hated that. All right. On this slide, you can see some fun trivia on me. I'm using Prometheus since 1.6, which was quite a few years ago. Now, soon we will have Prometheus 3.0, which is a great milestone. I was mainly using Prometheus at scale at LastPass, the password manager company. There we were running lots of Prometheus instances with lots of metrics and users. So we also needed tunnels to solve the long-term storage and decentralization problem. And what I really want to also do, apart from my day job, is to make the life of SREs and DevOps engineers easier. And you can also be part of that by scanning this QR code or go to that link. It's a GitHub issue it's a discussion that's already closed. But if you follow the links, you can find the issue that is still open, and that's about a UX improvement to the Grafana user. That's a UX improvement to the Grafana interface. If you are using both Prometheus and Grafana, then you must probably also have a similar feeling about the issue that is highlighted on this link. Just a very quick slide about Solo.io. Who is familiar with Solo.io? A couple of people, not that many as former Nagios users. Who is using Istio? A couple more? Okay, that's actually not too bad. Feel free to chat with me afterwards if you have any questions related to Istio or API gateways or application networking. Because that's what Solo is doing. Application networking is hard, but it doesn't have to be. we are providing a single simplified API over Istio and Envoy primitives so that you can have a consistent user experience to solve all of your application networking challenges. And obviously that comes with some observability challenges as well, and we are providing a solution for that too. This is the rough agenda. First, I will quickly introduce OpenTelemetry itself for the people who are new. And that's a useful section because that's where I will be discussing the differences between different OpenTelemetries that are out there. So that can help to clear up some confusion. Then we will move to a quick overview of the state of the world before OpenTelemetry. Then we will take a look at how OpenTelemetry aims to solve these problems. Then we will go through 3 case studies, and that will be the talk, basically. So let me move forward. Let's start with the OpenTelemetry 101. Everyone is talking about OpenTelemetry. You can see the Google Trends page. Not sure what happened in that spike in March. There's another, yeah, they started to measure things differently where they have the node, but there's a big dip, not sure what happened there, but the popularity of OpenTelemetry is clearly increasing. If anyone is aware of a better tool to gauge the popularity of given technologies, then feel free to help me with that out, because I don't really like to use Google products or Google Trends, but this is quite useful and the only thing that I could use to get this graph. A feature that is actually good thing about the Google Trends is that you can have a section like this, related queries, so that you can understand what kind of queries people are using when they are searching for the given terms. You can see on the left the state of the related queries from last year and from yesterday night. On the right-hand side, you can see it's slightly different, but what is clear is that there are different ways people are using to get some content on OpenTelemetry. You can see that we have a collector, we have Java, we have Prometheus. If you check the table from last year, you can also see Jaeger there. So it can be quite confusing how these are related to each other. So what is OpenTelemetry? This is the actual up-to-date definition of OpenTelemetry from their website. Last year it was much longer because a couple of months ago, they moved some of the original definition into the other section I will also show you. But this is actually quite good. It's much better than it was last year. OpenTelemetry is a collection of APIs, SDKs, and tools used to instrument, generate, collect, and export telemetry data, metrics, logs, traces, to help you analyze your software's performance and behavior. That's not that difficult, but there's lots of things there, APIs, SDKs, and tools. People can get confused how OpenTelemetry can be all 3. So let's try to make some sense of the definition. If you scroll down on the website or click next, then this is what you will see. And this is not necessarily making it easier. Some part of these bullet points was also part of the original definition last year. It's a lot of text. It's a framework, toolkit, vendor and tool agnostic, not an observability backend like Jaeger, Prometheus, and other commercial vendors. There's lots of stuff here. So when people are just starting out and reading paragraphs like this, they can be confused. It's not much clearer. There can be engineers who are giving up trying out OpenTelemetry after reading a few paragraphs like this. I actually wanted to try OpenTelemetry out after a few months it came out, and the docs was the most confusing piece of technical documentation I've ever seen. It got so much better now, but still the best is to read the readmes in the GitHub repos, which is not necessarily the best way to go about documentation, but at least that's up to date. And I also had to include this slide in the defense of the OpenTelemetry developers and end users and the docs team. It's very hard to come up with a proper definition if you want to be a Swiss Army knife of everything related to telemetry and solve all the problems in the ecosystem. I generally think that the OpenTelemetry collector and the operator is better, more production ready than the actual libraries and SDKs. That's just my personal opinion. It's different for each use case, but there are some shortcomings of OpenTelemetry as well. So let's try to make sense of the original definition. You can see that there are APIs and SDKs. So you can use the former ones, the APIs and SDKs, to instrument your application to emit observability data, telemetry basically. And you can also use the later ones to collect and transfer and ship this observability telemetry data to a destination. And one another important thing is that it might or might not originate from OTel instrumentation. So I created a few slides and diagrams to try to simplify this. OTel libraries and SDKs are not the same thing as the collector and the operator. But both of them are called OTel. So depending on what kind of person you are talking with regarding OpenTelemetry, if they are coming from a, let's say, developer background, they most probably mean the libraries and the SDKs by OpenTelemetry. So when you are talking with the developer and they are saying, okay, we need to implement OpenTelemetry in this project, they probably mean the libraries and SDKs, the actual instrumentation phase. While if you are talking with ops people, then they might mean the collector and the operator, because that's what they used to work with. Both of them are called OTel and OpenTelemetry, but these are different things. And the last part about the data that might be or might not be originating from OpenTelemetry instrumentation, this is the diagram, the illustration that I created. Because you can have an application that is using non-OTel libraries. Let's say the Prometheus client Golang library is the most popular way still, and in my opinion, the best way to instrument cloud-native applications in Go with Prometheus metrics. You can use those libraries. Those are not OTel libraries, and you can use that to expose the same kind of telemetry. And you can, even though that's not coming from official OTel instrumentation, you can still use OTel, OpenTelemetry, the collector, to collect these and push that to any OTel compatible backend. Obviously, if you are using native OpenTelemetry instrumentation, then you can still do the same, obviously. But the point of this illustration is that you don't necessarily have to use the OTel libraries if you want to get the data in an OTel format into an OTel backend. This is a specific configuration and illustration of what an OpenTelemetry collector would look like. On the left, you have the workloads. That's your application. That's your web shop. That's your, I don't know, any kind of component. And on the very right, you have any kind of backend that you can imagine. That's Datadog, Prometheus, Loki, Tempo, Elasticsearch, Honeycomb, Zero. Anything can be on the right-hand side. In the middle, you have the collector. You can see that the collector has 3 stages. The first is receivers. That's the way to get some data into the collector. Those are actual receivers. You can provide your scrape config there to scrape metrics. You can use another receiver, for example, the file log receiver to tail logs from the disk or from std out. Then in the middle section, you have extensions and processors. That's where you can transform, enrich the metrics, the telemetry data, not just metrics, logs, and traces as well. Do some customization, and then finally you have the exporters that you can use to push the data to any of the backends on the right. I will give you a couple of other slides later on to show you different configurations and why this can be a good idea. So let's move forward and take a look at what the world looked like before OpenTelemetries were deployed to lots of clusters out there. If you were using OSS tools, then you most probably used these or similar projects to get metrics, logs, and traces into a backend. That's Prometheus, FluentD, FluentBit, and the Jaeger logo. These tools are fine. They are more than an actual collector. For example, Prometheus is actually a TSDB implementation. You can store metrics there. You have service discovery. You have lots of other features. And all the other projects are also a little bit more than the collector. The collector shouldn't be an end-to-end solution for OpenTelemetry, for telemetry purposes. But these were the tools that people usually used and might be still using to monitor their infrastructure. On the dark side, if you are paying for a SaaS vendor, you are probably using their agent to get some telemetry data into their SaaS backend. If you were using, for example, Datadog, then you most probably, before OpenTelemetry, were using the Datadog agent to collect the telemetry data and forward it to the backend. These agents were usually tedious to configure, had vendor-specific assumptions on what you wanted to or what you can do. They were not very easy to operate. They had, in some cases, some centralized factor in them, so you couldn't really have specific agents for specific telemetry types. And in my experience, they all left something else to desire. So let's take a look at the promise of OpenTelemetry. Let's go back to the slide that I showed you earlier. This is the very same, this is an actually simpler illustration than I showed you before. You can see that your application is on the left, on the right, and you have all the backends that you can possibly imagine. And in this example, you can see that we have a Prometheus receiver. Prometheus receiver is basically a scrape configuration that is very, very similar to a Prometheus scrape config. You can specify what kind of targets you want to scrape, and then you have the data in your collector. Let's say you have some cardinality, high cardinality metrics ingested by the collector. Then you can use the processor sections in the middle to transform that data. You can drop the high cardinality metrics, you can simplify them, you can do lots of things. And then you have the exporters section where we have Datadog specified. So with this configuration, you basically replicated what a Datadog agent could do. You are getting metrics from the workloads, and you are pushing them to Datadog. Another option that you can do in an OpenTelemetry connector is that you can add another receiver. Let's say you can add the file log receiver. The file log receiver is mounting the logs from the host node, and you can read the files from the disk. So you have the access logs, for example, from your API gateway or your ingress controller. You can do any kind of customization that you want, just like you would. You have the option with for the metrics, and you can also push them to Datadog. The only thing that you need to change is that you needed to add a file log receiver that is doing that. You can have a centralized agent that is getting you both metrics and logs. You can also run multiple replicas of the collector, where you can have a dedicated collector for logs and another for metrics, and the third one for traces. But you are using the same component, basically the same configuration, and the same ecosystem around it, the same integrations. You can push everything to Datadog, for example. And just to make it more interesting, check this out. You can add another receiver, let's say an OTLP receiver, because you also want to do traces. In your dev environment, let's say you don't want to pay for Datadog because you don't have that kind of money to pay for Datadog in your dev environment. That happens to most of us. In that case, you can configure the collector with an OTLP receiver so that you can push the traces in OTLP format to the collector, do some processing, and you can see that in the exporter section, we added another OTLP exporter. That OTLP exporter is a generic exporter that you can configure with any kind of endpoint and potentially with some headers. If you are using a SaaS backend, then you probably have a access key or some sort of header to specify your tenant in the SaaS. But basically, that OTLP can also point to an open source solution, for example, Tempo. Grafana Tempo from Grafana Labs, which is, or Jaeger, which are tracing backends. And you can use the same components, the same pipelines, the same everything, and you can choose where to send the data without, I don't know, using something for Tempo, something for the other OSS projects, something for log processing, and a completely different sets of applications deployed in production where you actually want to leverage this as solution. So the promise of OpenTelemetry collector really is to provide a portable, unified way to think about telemetry. You can use these receivers, processors, exporters, and all this ecosystem around it to push the data anywhere. Let's say you want to move away from SaaS vendor A because it costs too much. Traditionally, without OpenTelemetry collectors, you would need to migrate from their proprietary agent to the other SaaS vendor B agent to do the migration. With OpenTelemetry, you can just hook another exporter into the configuration and start sending data there. Which can greatly reduce the cost of a potential migration. People say that people don't always or don't frequently migrate to another observability vendor because they are already too invested in a specific vendor. I don't personally believe that's true. There can be cases, there can be situations, there can be scale, there can be certain scales where it definitely makes sense to move away from one vendor to another or even to self-hosted solutions because the price is just usually crazy high. Now let's go through some scenarios and take a look at when it makes sense to use OpenTelemetry collectors, what's the difference with Prometheus, what kind of different scenarios we can imagine. When I'm not specifically calling out other telemetry signals, I'm focusing on metrics in the following slides. So let's take a look at scenario one. I'm a cloud architect working on my company's infrastructure. We are managing hundreds of Prometheus instances across multiple on-premise DCs and Kubernetes clusters as well. And these architects might get the idea of migrating everything to OpenTelemetry collectors because there's a Prometheus receiver and that can do all the job. People might not be happy with that because if everything is working fine, then why should we change anything? Some of them might not even understand how you can use a collector instead of Prometheus. They can be confused. So first, let's take a quick look at how this is even possible. As I mentioned, there's the Prometheus receiver. You can find it in the contrib repository of OpenTelemetry. And you can use this, as I mentioned, with the scrape config, very similar to standard Prometheus scrape config to scrape the metrics. However, it's not a 100% replacement for Prometheus. This page calls out a couple of warnings and unsupported features. You cannot do alerting. You cannot do remote read, for example. If you want to solve sharding, you have to do that manually or implement that logic yourself. If you are scraping with an OpenTelemetry collector, then that becomes a somewhat stateful component compared to just a push-specific stateless component. So there are some edge cases where, not just edge cases, there are some situations where it might not make sense. I recommend going through these questions with the team in charge to come up with a good solution. For example, is there any problem with the current solution? What are the failure modes of the current solution? And how these will change with the proposed new OpenTelemetry compatible model? What happens if a Prometheus dies? What happens if a collector dies? How can you scale them, for example? What if you have impaired connectivity between Prometheus and your backend that you are pushing to? What happens if you don't have access to your centralized backend, but you still want to have query capabilities in the isolated cluster? Obviously, if you have Prometheus, you have local query capabilities, even without being able to push to Thanos, for example, or Mimir, or to the SaaS backend if the SaaS backend is down. But with OpenTelemetry collector, you cannot execute PromQL queries or any kind of queries really on purely the collector itself. What's the probability of all these failure modes that I listed here? At the very end, I will have a blog post listed from my side. You can visit that goes through all the Prometheus failure modes. I should probably write another one for OpenTelemetry collector failure modes so people can be aware of these failure modes and they can prepare for that. Another question, Prometheus agent mode. Prometheus agent mode provides a remote write capability that you can use to push data out of the agent. There you are also losing the query capabilities, but the resource usage and performance is much higher. So why not changing everything to Prometheus agent mode if we don't care about the local query capabilities and alerting? I don't have an answer to these questions. These are all specific to the given environment, but these are the questions that people should start with if they are considering a migration like that. Let's move to, so yeah, the conclusion is that it's a maybe. You should go through all these questions and decide for yourself. There are some cases where you can use this, or there are some cases where you can use a mix of OpenTelemetry collectors and Prometheus, depending on your risk tolerance, for example. But there's no yes or, it's not a yes or no question. This is scenario 2. You are working with a SaaS, or you are working on a SaaS as an SRE, and you are running one or multiple proprietary observability agents. The vendor claims to be a core contributor to OpenTelemetry. Should I switch to OpenTelemetry collectors? In this case, these are the questions that I think people should discuss internally. What kind of telemetry data you are using? Is it only traces, or is it only metrics, or logs, or traces, or all of them? Do you have dedicated components? What's the risk of of any kind of telemetry signal affecting other kinds? What's your observability strategy? Are you happy with vendor A, or are you considering moving away to vendor B? And do you think that, and you are thinking that in that migration, migrating to OpenTelemetry can help? It can definitely help, but you should also consult with the vendors, both vendors, or most probably more likely the new vendors limitations page, because there can be features that are not fully supported, and the cost can be also higher. For example, there are observability vendors out there who only support ingestion coming from their agents without paying for a premium for that. So anything coming from a custom OpenTelemetry collector might be considered custom metric, custom telemetry, and they might charge some extra on that. So this is another consideration people should be aware of. And you should have a well-defined migration plan where you can do this in a phased manner, in a way that everything is compatible with the before and after state. Generally, I would say this is a good strategy, especially if you want to move away from one vendor to another, but it's key to keep track of the limitations and the cost implications. And this is the third scenario, the last one. I'm a vendor delivering an observability solution. Should I make my telemetry pipelines, and how should I make my telemetry pipeline scalable, both in terms of ingestion, procession, and integration? Let's say you are a SaaS, you are providing some kind of service, most probably in the infrastructure world, otherwise you wouldn't have a telemetry pipeline. Should you create an agent from scratch or use your existing agent to do that? This is actually the way we were doing that at Solo in a long time ago. We already had an agent on the workload cluster. We also have a management cluster. Everything is self-hosted. It's not a SaaS. So you have a management cluster and a workload cluster, and you have communication between the two via an agent. And the agent already had other responsibilities. Kubernetes, but we were also using that agent to collect all the telemetry data and push that to the worker cluster. Obviously, there were some issues with that. As I mentioned, the agent had other responsibilities. You couldn't really filter the metrics. It was metrics only. You couldn't support logs. You have to add all these capabilities into the agent, which was not a good idea. You couldn't control cardinality issues. It was just not a good solution to use an existing agent for this job. And it's similarly also not a good idea to start with an agent or proxy from scratch, because you probably can't beat the ecosystem and integration that OpenTelemetry collectors can nowadays provide. So this is our new design. We have a telemetry collector running in the worker cluster and a gateway deployment of the collector in the management cluster. So you can collect all this data, logs, metrics, traces. You can do the processing. You can get rid of the cardinality issues while keeping the important metrics for the management server and the UI in a proper format and under control in the management server. Then you can push to any kind of observability solution, because our users are using lots of different observability solutions, so we don't want to limit them. So in this case, I would say this is definitely an approved solution. If someone is, as a vendor, starting out, they shouldn't necessarily build their own new agent from scratch, because of the mostly because of the integration and the ecosystem of OpenTelemetry. Just this week, there was a new a new observability agent announced. I won't name it, not sure if some people might have heard of it yet, but I'm a bit skeptical about that direction, because OpenTelemetry is actually a technology and the CNCF project that people actually use. There are some that no one uses, but OpenTelemetry is getting more and more popular. So the takeaways, not too much. It's just always make sure that you are articulating which OpenTelemetry you are talking about. I created those slides to make those discussions easier. OpenTelemetry is not a silver bullet, so you should pay attention to all the trade-offs and questions about the potential migration. And if you are a SaaS vendor, don't reinvent the wheel. These are the references. The slides will be available, so you can find them on the website. And you can join our Slack channel if you want to have a discussion about application networking or telemetry here. Thank you, everyone, and I wish you a great conference.
All right, thank you for this great session. Seems like we don't have any questions loaded. Am I? Because we have quite a bit of issue with our Slido app. But anyway, what's going on here? So I actually have one question about your talk. So as the weeks and months goes by, we see more and more collectors in the wild being built, shared, open sourced, or open core. For someone who just jumped in and just discovered what OpenTelemetry is and what it does, what would you recommend? Like, I don't know, testing all of them, or just going to the most popular one, have a clear overview? What do you think?
Like what kind of, which OpenTelemetry collector people should use? That's a great question. So if your vendors are providing one, then to get the best user experience and features, you most probably should use the one provided by the vendor. That's what they also support. So you have an actual SLA probably for that component. If you are just starting out at home or you are just trying to get familiar with OpenTelemetry and the ecosystem and the configuration of OpenTelemetry and all this, then you can just use the contrib distribution, which has all these integrations and exporters and processors that I discussed and more. You can go to the OpenTelemetry collector contrib GitHub repository and see what kind of it has a crazy list of integrations and processors. So that's a good starting point. After you know what you need and you are not a vendor, then you can and you are just, I don't know, an SRE or a DevOps engineer or platform engineer working on your platform, then what I would recommend is to build your own collector. You can do that by only enabling the components that you know that you will need, and that will be a much more performant and lightweight and tailor-made solution for your use case. But if you're just starting out, you can start with contrib or with the one that the vendor provides for you.
Got it. Thank you very much. We are good for this session. Thank you very much for this very interesting session. And please, can I get a big round of applause for our speaker?
Thank you.